Okay, so this is going to be a video over section 2.6. I like to call this section the library of functions. It's going to be talking about the basic functions that we'll be working with for the first part of the semester. First of all, let's talk about what continuity is. Basically, a function is going, or any kind of function is going to be continuous as long as you are able to draw it without lifting your pencil from the paper. If a function is not continuous at a certain point, then it's called a discontinuity at that point. So you'll look at example number 1. You're asked for the intervals of continuity. Now, the first thing that I want you to notice is that there is a place in this graph that is discontinuous. That open circle shows me that I cannot touch that specific spot. So my intervals of continuity then are going to be everything on this side of that discontinuity, and then also everything on this side of that discontinuity. So when we are writing down our intervals, our first interval is going to be from negative infinity to 0. That's going to take care of all of this from negative infinity to 0. And then on the other side of that, let's see if it'll let me move that here. And that's going to be from 0 to positive infinity. If you are looking at the next example, there are no places of discontinuity, so this one is continuous over all real numbers. Now, notice that for the library of functions, I'm asking you to memorize 3 things. There's no way around this. You just simply have to memorize. So you need to know the name of every function. You need to know what the graph looks like. And this includes some important points. So not just the generic shape, but you actually need to know specifically where does this parent function lie. And then thirdly, you need to know the equation. These are the 3 things that you need to memorize about every one of these parent functions. And that's what I'll be calling them, the parents. Later on, we'll be messing with the parents. We'll be moving them up or down or right or left or squishing them or stretching them. So the parent functions, notice that the very first one that we have here is going to be the identity function. So that's the name that you have to memorize. Secondly, I've given you 2 graphs. One looks like it came from the graphing calculator. The other one is just a normal graph. Notice that the important points here, because of the fact that my y value is equal to my x value, all of my x's and my y's match up. So I have 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 4, etc. So all of my x's and my y's match up. So that's the name of it, that's the graph of it, and then the third thing that you have to have memorized is the equation. So that's going to be y equals x. You can look at the graph at this point and be able to tell that what the domain is. So the domain is not something you have to memorize as long as you know what the graph is. The domain is going to be all real numbers. The range will also be all real numbers. Notice that this particular function is increasing on its entire domain, and it is also continuous on the entire domain. All right, the second parent function that we will be working with is going to be the squaring function. So the name of this one, the squaring function. The equation right next to it, so this is going to be y equals x squared. Notice that you have a graph here, and I want to point this one out because we're actually going to spend a lot of time talking about the squaring function in weeks to come. So let's get a good hold of it right now. The special points that I want you to notice, first of all, this 0, 0 is the turning point. If you go to the right one and up 1, to the left 1 and up 1, you'll get 2 special points. And then if you'll go to the left 2, 2 squared is 4, And if you'll go to the left 2 and up 4, so right or left 2 and up 4. So what I like to say on this one is that if you go right or left 1, you're going to go up 1. If you go right or left 2, you're going to go up 4, because 1 squared is 1, 2 squared is 4. These are what I would call the special points for the parabola. The domain is going to be all real numbers. The range, remember this is from bottom to top, so this is going to be from 0, including 0, to infinity. This graph is going to decrease, first of all, it's going to decrease from negative infinity to 0, and then it's going to turn around and increase from 0 to infinity. It is always going to be continuous. All right, parent number 3. Parent number 3 is the cubing function. And its equation is going to be y equals x cubed. Again, notice that on our graph here, we've got a special point 0, 0, 1, 1, because 1 cubed is 1. We also have negative 1, negative 1. 2 cubed is 8. Negative 2 cubed is going to be negative 8. Let's see here, 2, 4, 6. There we go. So I would call those the special coordinates on the cubing function. The domain is going to be all real numbers. The range is also all real numbers. It's always going to be increasing, and it is always going to be continuous. The fourth parent is the square root parent. And its equation is going to be y equals the square root of x. So when you're looking at the special points on this one, 0, 0, of course, because the square root of 0 is 0. The square root of 1 is 1. I don't know what the square root of 2 or the square root of 3 is without using a calculator. So I'm going to go all the way down to the square root of 4, because that one's a pretty one. Square root of 4 is 2. And so I would consider these the 3 most important points on my square root graph. My domain, notice it's starting at 0 and going all the way to the right to infinity. The range, the bottommost y value, is also 0, and it's going up to infinity. It's always increasing from 0 to infinity, and it's always going to be continuous on the entire domain. And I'm not sure if your notes were missing this or not, but on this domain here, my notes were missing a square bracket, so you want to make sure you put that in. All right, the fifth parent is going to be the cube root parent. So that's the name of that one. Y equals the cube root of x. It's going to be its equation. Some special coordinates. You've got 0, 0, 1, 1, or negative 1, negative 1. The next pretty cube root is not until the cubed root of 8. And the cubed root of 8 is 2. The cubed root of negative 8 is negative 2. So that's why in your table of values here, it's spread out so much. None of the other cube roots are nice and pretty to work with. Notice that my domain, by looking at the picture, is all real numbers. My range is all real numbers. It's always increasing, and it is continuous. Now, before we talk about the absolute value function, I do want you to see the definition of absolute value. I realize that in your mind, you probably think, okay, absolute value just means anything inside is going to be positive. And that is a true statement, but if I'm going to write that in a geeky way, this is how I would write the definition of absolute value. Let's go ahead and talk about the parents. The absolute value function is the name of the parent. Y equals the absolute value of x is the equation. We call this the V-graph. I know that's really creative there. But we have 0, 0, because the absolute value of 0 is 0. Absolute value of 1 is 1, so 1, 1. 2, 2, 3, 3, 4, 4, etc. On the negative side, the absolute value of negative 1 is positive 1. The absolute value of negative 2 is positive 2, etc. So it's the V-graph. My domain is, once again, all real numbers. My range, the bottommost value is 0, so it's going to go from 0 to infinity. It's going to decrease from negative infinity to 0, and then it turns around and increases from 0 to infinity, and it is always continuous. So this is the library of functions. Make sure you take the time to memorize those 3 things. Memorize the name of every parent, memorize the equation of every parent, and memorize the graph along with a few special points on every parent.